Hello students, welcome back. In the previous video, we have seen introduction to the syllabus. In this video, we are going to see introduction to the first chapter, real numbers. So what is the real numbers and which type of number system we are having? Let's see now. So in the real numbers, before coming to the real numbers, all of us know what is the natural numbers. So let's see all the number systems. First, let's see what is the natural numbers. So natural numbers, what is the natural numbers? The natural numbers are nothing but the numbers which are countable. 1, 2, 3, 4, 5 like this. We count any numbers like this only, right? So this countable numbers we call it as natural numbers. So the first number system which we are having is natural numbers. So what are the natural numbers? Generally we denote natural numbers with capital N. Natural numbers with capital N. So the natural numbers are we are having as 1, 2, 3, 4 up to so on. So here the question can be asked, what is the least natural number? So the least natural number is 1, and the highest natural number, can we say what is the highest natural number? We cannot say, because if I say the highest natural number is 1 crore, so 1 crore 1 will be there. So if I say 10 crore 1 will be there. So like this we can say the end of the natural number is undefined, or we can say infinity. We cannot say, right? So this is about first number system, natural numbers, right? The next thing is, if we add 0 to the natural numbers, we call that number system as whole numbers. So the second number system which we are having is whole numbers. So whole numbers we denote it by W. So this already we have learned in the lower classes, but again once recapping it, whole numbers we denote it by W, and the whole number starts from 0. 0, 1, 2, 3, 4 up to so on. So you can say the least natural number is 1 and the least whole number is 0. Okay students, here one type of question can come. So please note this, whether every natural number is a whole number? Yes. So you can note this, every natural number is a whole number, but every whole number need not be a natural number. అంటే ఏంటంటే నేచురల్ నెంబర్ అయిన ప్రతి నెంబర్ కూడా హోల్ నెంబర్ అవుతుంది, బట్ హోల్ నెంబర్ అయిన ప్రతి నెంబర్ నేచురల్ నెంబర్ కానవసరం లేదు. ఎలా చెప్పండి? సపోజ్ 1 తీసుకుంటాను, 1 హోల్ నెంబర్ అయితే నేచురల్ నెంబర్ కూడా అవుతుంది, 2 హోల్ నెంబర్ నేచురల్ నెంబర్, 3 హోల్ నెంబర్ నేచురల్ నెంబర్, బట్ 0 is a whole number but not natural number, right? 0 is a whole number but not a natural number. Next one is, third one is integers. So generally we denote integer by I or sometimes Z, I and Z. So here integers we are having two types of integers. In fact, one is a positive integers and negative integers. You can say it starts somewhere -3, -2, -1, 0, 1, 2, 3 up to so on. That means other than the whole numbers we are having the negative numbers also. Then this number system we call it as a integers. So whether for integer, what is the least integer? We cannot say any least integer. What is the highest integer? We cannot say highest integer also. Coming to the integers. Okay students, so now integers divide into two parts, and this is the first one is called positive integers. 0, 1, 2, 3 as a positive integers. In fact, whole numbers are positive integers, both will be same, and these are negative integers. So positive integers generally we denote it by Z plus. Integers we denote it by Z, right? So Z plus is nothing but it is a positive integers. Here negative integers we denote it by Z minus. That means integers with negative numbers. This is the integers with positive numbers. Okay students, so integers we are having positive integers and negative integers. Positive integer denoted by Z plus, and negative integers we denote it by Z minus. Okay students, now here one more thing we can say, same like previous example, every integer is a whole number but every whole number need not be an integer. every integer is a whole number, but every whole number need not be integer. ఎందుకంటే నెగిటివ్ నెంబర్స్ ఉంటాయి కదా, హోల్ నెంబర్స్లో నెగిటివ్ నెంబర్స్ ఉంటాయి ఉండవు, బట్ ఇంటీజర్స్లో నెగిటివ్ నెంబర్స్ ఉంటాయి. ఓకే స్టూడెంట్స్, దిస్ ఇస్ అబౌట్ థర్డ్ వన్, ఇంటీజర్స్. అండ్ నెక్స్ట్ ఫోర్త్ వన్ is a rational numbers. Fourth one is a rational numbers. So generally we denote rational numbers by what? Quotient, Q, right? So the rational numbers, what is mean by rational numbers? All of you know, right? You have learned in the 8th class itself. What is a rational number? Rational number is nothing but a number which is in the form of P by Q, right? The number which is in the form of P by Q, that means numerator and denominator, then we can say that number is called rational numbers. So in fact the definition what we can write is, I'll rub this. Rational number is nothing but the number in P by Q form, right? The number in P by Q form where Q is not 0, Q never be 0. అంటే డినామినేటర్ ఎప్పుడు కూడా 0 ఉండద్దు. ఎందుకు ఉండద్దు? ఇఫ్ ద డినామినేటర్ is 0, that is a undefined. Okay students, so Q is not 0. And what about PQ? PQ are positive integers. So here the number in P by Q form where Q is not 0 and P comma Q belongs to Z plus or positive integers, we can say that number is a rational number. Example, you can say 3 by 2, is it rational number? Yes, it is in P by Q form and Q is not 0 and P and Q are positive integers. Okay, you can say 2 by 3, this is also a rational number. Whether 3 is a rational number? Yes or no? No, this is a rational number because 3 I can write as 3 by 1. 3 I can write as 3 by 1. So it is in the form of P by Q, then 3 is also a rational number. Whether 0 is a rational number? Yes, 0 is also a rational number. I can write 0 as 0 by 1, right? So 0 I can write 0 by 1. So 0 by 1 is also a rational number. So this is also a rational number. That means every integer is a rational number. So this is a rational number because minus 3 I can write minus 3 by 1, minus 2 by 1 I can write, minus 1 by 1 I can write, 0 by 1 I can write, 1 by 1 I can write, 2 by 1 I can write, 3 by 1 I can write. That means every integer is a rational number. Okay students, so every integer is a rational number. You can write here, every integer is rational number. So every integer is a rational number, but every rational number need not be integer. Need not be integer. Here you learn it. We know every integer is a rational number, but every rational number need not be integer. If I take any number 2 by 3 is a rational number, but is it integer? It's not an integer. Okay students, now so these are all rational numbers. So other than the rational numbers, we are even having the fourth one is irrational number. Fifth one is irrational numbers. So generally we denote irrational numbers by S. Okay students, or else we denote it by Q dash. Irrational number we denote it by Q dash. Q dash is nothing but other than Q. Q dash is nothing but other than Q. So these are the number system we are having: natural numbers, whole number, integer, rational number, irrational numbers. But our topic is real numbers. So what is the real numbers? So real numbers is nothing but all these numbers we call it as a real numbers. So if you take a diagram like this, the smaller part of a real number is a natural number. So this is a natural number, right? For natural number, if we add 0 to the natural number, it will become whole number, right? So if we add 0 to the natural number, the number is coming as whole number. So we can say n is a subset of w. So n is a subset of w. W is a whole number. Next we can say if we add the negative number to the whole number, if we add negative numbers to the whole number, we are going to get the integers, right? So we can say W is a subset of Z. N is a subset of W is a subset of Z. So if we take any number in the form of P by Q, we are going to get a Q. We are going to get Q. So this is all rational numbers. So in fact, all these are rational numbers, right? So rational numbers. So N is subset of W, is subset of Z, is subset of Q. Right? Q is the bigger number system. Now, whether is it real numbers? So real numbers is nothing but the separate numbers is there. This is a irrational number. So these are all rational numbers. This is a irrational number. So total this part, rational and irrational number together we call it as a real numbers. So what is the real numbers? The rational number and irrational number put together we call it as a real numbers. So this total we call it as a real numbers. Right? So real number is nothing but Q. Q is a rational number plus Q dash is an irrational number. So Q and Q dash we call it nothing but the union of rational number and irrational number is called real numbers. So this is the introduction to the real numbers. So what you are having in the real numbers is the mainly we are having the decimals. So for coming to the rational numbers and irrational numbers, which type of decimals we are having, let's see now. And also we are going to see in the next video we are going to see 1.1, exercise 1.1. In this video we are going to see the concepts related to 1.1. Okay students, so any doubts you can post me in the comment section, you can write in the comment section, so that will be addressed in the next session. Okay students, so this is about introduction to the real numbers. So now what we are having in the real numbers? The next part we are having in the real numbers is, right, next if you see the page number 3, the one question is there. What is the question? So let us see all the example problems, then you can do exercise problems. The first question we are having is represent 5 by 3 comma minus 5 by 3 on number line. So all of you know how to represent this on the number line, right? So how to represent this number on line? So this is a number line, all of you know that 0, 1, 2, 3 and the left hand side it is minus 1, minus 2, minus 3 like this. So we are having minus 5 by 3 and 5 by 3. So how to represent this one? 5 by 3. 5 by 3 is nothing but 1 by 3, 2 by 3, 3 by 3, 4 by 3, 5 by 3. So you write like this. Whatever the fraction is given, 5 by 3 as 1 by 3, 2 by 3, 3 by 3, 4 by 3, 5 by 3. So come in here, 3 by 3 is nothing but what? 1. Next 6 by 3 is nothing but 2. So 1 in the denominator whatever the number is there, so divide this into that many parts. If it is a 5 by 4, divide into 4 parts. If it is 6 by 5, divide into 5 parts. So now 0 to 1 divide into how many parts? 3 parts. So 1 part, 2 part and this is the third part. And also this is also 4th part, 5th part, 6th part. Same way negative sides also 3 parts, 1 part, 2 part, 3rd part. 1 part, 2 part, 3rd part. Like this you divide. So you can write this 1 as 3 by 3. 1 as 3 by 3, 2 as 6 by 3. And left hand side it is this 1 as minus 3 by 3 and this as minus 6 by 3. So if you are able to represent like this, you can easily write what is a 5 by 3 and what is a minus 5 by 3. So this is 0, right? After 0, first one is 1 by 3, second one will be 2 by 3 and third one will be 3 by 3, fourth one will be 5 by 3 and fifth one will be 4 by 3 and 5 by 3. So this is the 5 by 3 representing on the number line, right? 5 by 3. And coming to the right hand side, left hand side, this is a minus 1 by 3, minus 2 by 3, minus 3 by 3, minus 4 by 3, minus 5 by 3. So here you should remember that whatever there in the denominator, if it is a 1 by 2, divided into 2 parts. If it is a 1 by 3, divided into 3 parts. Okay. So on the number line dividing represent 5 by 3 and minus 5 by 3 is this is the 5 by 3 and this is the minus 5 by 3. Okay students, I hope you have understand. Suppose let us take one more example. What is 2 by 3? Or else you take 2 by 5. How to represent 2 by 5 on the number line? So how to do 2 by 5 means this is a 2 by 5 is nothing but 1 by 5, 2 by 5, 3 by 5, 4 by 5, 5 by 5 like this. So this is 0 and this is a 1. So how many parts we need to divide this into? 5 parts. Whatever the denominator is there, that many parts you divide. So this is a 1, 2, 3, 4, 5. This is the 5 by 5. Now what we want? We want 2 by 5. That means this is a 1 by 5. This is a 2 by 5. So you have learned in the 8th class itself, but again it is given in the 9th class. So this is a way to represent a fraction into on the number line. Okay students, the next type of problem we are having is the second problem. In the page number 3, the second problem we are having is, are the following statements true? If you see the second problem, are the following statements true? Give reasons for your answer with an example. What is the question we are having? Every rational number is an integer. Is it true or false? Whether every rational number is an integer? No. Because 2 by 3 is a rational number but not an integer. Any example you can take. 5 by 6 is a rational number but not an integer. That means every rational number is not an integer. That is the first question. Second one we are having is, every integer is a rational number? Yes. Already we have discussed. Every integer is a rational number because the integers we are having minus 3, minus 2, minus 1, 0, 1, 2, 3. So these are all the integers, right? So we can write minus 3 as minus 3 by 1. So that will become an integer, a rational number. So every integer is a rational number. We can convert every integer into rational number. So we can finalize that every integer is a rational number, but every rational number need not be an integer. The next question they have given, whether 0 is a rational number? Yes, 0 is a rational number because 0 we can write 0 by 1 or else we can write 0 by 2, 0 by 3 like this we can write. So because 0 is an integer, so integer we can write 0 by 1, 0 by 2, 0 by 3 like this. So it is a rational number. Okay students, the next problem we are having is, find two rational number between any two numbers. So the question is, find two rational number between 3 and 4 by mean method. Find two rational numbers between 3 and 4 by mean method. So this is the important one. Definitely they may ask in the examination, what is the mean method? So we need to insert two rational numbers. Insert two rational numbers between 3 and 4 by mean method. So how to do this problem is, they may give any question, like they may give insert 5 rational numbers between 4 and 5 they may ask. They may ask insert 4 rational numbers between 6 and 7 they may ask. How many numbers they ask, right? The process is same, using mean method. In the textbooks they have given two methods, but you learn only one method, second one you can easily do, right? The important method is, whenever they ask, insert 2. Whatever they ask, insert 2 means what you do is 2 plus 1. 2 plus 1 will be how much? 3. Right? 2 plus 1 is how much? 3. Now what you do is, if they ask insert 2 numbers, you do 2 plus 1 is equal to 3. If they ask 5 numbers, you do 5 plus 1 is equal to 6. If they ask 4 numbers, you do 4 plus 1 is equal to 5. Right? So now what you do is, 3 is there, right? And it is a 4. So for 3, what you do is, 3 by 3, do 3 by 3 and They are asking us to insert 2, right? So 3 I am writing 3 into 3 by 3, and 4 is there. 4 I am writing as 4 into 3 by 3. So I am converting 3 to 4, 3 and 4 to any rational number. So 3 as 3 into 3 by 3, because 3 by 3 is a 1 only, right? So this I can write as 9 by 3. This I can write 12 by 3. Understanding what I am doing? I am having 3 and 4 here, right? I am having 3 and 4. I need to insert 2 numbers between 3 and 4s. Right? For that, what I did is, I want to insert 2 numbers. So I am taking 2 plus 1. Whatever the number is given. If they ask us to insert 5, you take as 6 number. If they ask us 4, you take 5. Okay? 3 and 4. First thing, 3 into 3 by 3. And next one is 4 also into 3 by 3. So 3 I can write 3 into 3, 9 by 3. And 4 I can write 4 into 3, 12 by 3. Now here 9 by 3. After 9 by 3, after 9 what it will be? 10, right? So 9 by 3 and this is the 12 by 3. Now this will be 10 by 3 and 11 by 3. Next 12 by 3. So these two are numbers in between 3 and 4. So this is a way to insert 2 rational numbers between any 2 rational number. Not only 2. If they ask one more question, let us take this one. 4 and 5. So first we'll write 4 and 5. How many numbers they asked us? 6, right? 5 plus 1 means 6. Right? So what you do is 4 into 6 by 6. Here 5 into 6 by 6. So 4 into 6 by 6 is how much? 24 by 6. And here 30 by 6. So in between 25 by 6, 26 by 6, 27 by 6, 28 by 6, 29 by 6. So how many numbers we got? 5 numbers. So this is the way to insert any given numbers into 2 between rational numbers. Right, students? So this is about introduction to real numbers, and we have learned how to represent a fraction into the number line, and also we have learned the mean method, how to insert 2 or any numbers between 2 rational numbers. Okay, students? So this is about today's class. In the next class we are going to see decimal numbers, what type of decimal numbers we are having, and also we are going to solve the exercise 1.1 in the next class. Okay, students, I hope all of you are following. You write down the notes, and also if you have any doubt you can put in the comment section. In the next class we are going to solve your query. Right, students? Thank you very much. Let us meet in the next class. Okay, students? Right.